Pure Mathematics, Paper 1, Wednesday, 5th June 2019. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Given that x plus 3 is a factor of f of x, find the value of the constant a. F of x is 3x cubed plus 2a squared, 2ax squared minus 4x plus 5a. So to solve this question, we use the factor theorem, which states that if f of x is a polynomial, then f of p is equals to 0, then x minus p is a factor of f of x. So if x plus 3 is a factor of f of x, that means f of minus 3 is equals to 0. So we're going to substitute x equals to minus 3. So we substitute x equals to minus 3 in the polynomial, and that will be equals to 0. So 3 times minus 3 cubed plus 2a times minus 3 squared minus 4 times minus 3 plus 5a equals to 0. 3 times minus 3 cubed is minus 81 plus 2a times minus 3 squared is 9. 9 times 2 is 18. That gives you 18a. Minus 3 times minus 4 is 12. So minus 81 plus 12 gives you minus 69. 18a plus 5a, it gives you 23a. So minus 69 goes to the right, it becomes plus 69. Times 23 goes to the right, it becomes divided by 23. So 69 divided by 23 is 3. So A is equals to 3. Question number 2. Figure 1 shows a plot of part of the curve with equation y equals to cos x, where x is measured in radians. Use diagram 1 to show why the equation cos x minus 2x minus a half is equal to 0. So only one intersection means there is only one root. There's only one point of intersection between the line and the curve. That's the curve there, and that's the straight line. It's only one point of intersection. That means there's only one root. Now let's try and see how we can get the equation of the line. If we take minus 2x to the right, it becomes plus 2x. We take minus a half to the right, it becomes plus a half. So we have cos x on the left is equals to 2x plus a half on the right. So on the left is cos x, which is this graph there. On the right is the line 2x plus a half, which is that line there. So because it's equal, you want to find where the graph and the line, where do they meet? Because they are equal, they meet there. And they only meet at one point. So that means there's only one intersection and there's one root. So you plot the line y equals to 2x plus half on the diagram, and you make sure you have the correct gradient and correct intercept. When you do it, you draw it correctly to get the full mark. Given that the root of the equation is alpha, and that alpha is small, use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. For small angle approximation, cos x is equals to 1 minus x squared over 2. That is given to you in the formula book. So you just write 1 minus x squared over 2 and make sure x is in radians. Now you would replace cos x, all of cos x, you replace it with 1 minus x squared over 2. That comes from the formula book for small angle approximation. 2x stays the same, minus a half stays the same, 0 stays the same. Now, to get rid of the 2 in the denominator, you times everything by 2. So 2 times 1, 2 times that, 2 times that, 2 times that, 2 times that. So 2 times 1 will give you 2. 2 times this one will cross out with that 2. 2 times 2x will be 4x. 2 times a half would be 1. Now you put this as a quadratic. X squared minus 4x. 2 minus 1 is 1. So you have minus x squared minus 4x plus 1 equals to 0. You can multiply by minus 1 to get x squared plus 4x minus 1 equal to 0. Use your calculator. The number in front of x squared there is 1. The number in front of x is 4. The number on its own minus 1. And that will give you two answers. Minus 2 plus root 5. Or 0.236, which is what you want. An estimate to 3 decimal places. So you want to put 0.236. That's question number 3. Show that dy over dx is equals to a over x plus 1 to the power n, where a and n are constants to be found. So for question number 3a, this is where we start, and this is where we want to end. So we want to, at the end, we have dy over dx. So we want to show that dy over dx. So that means we have to differentiate. To get from y to dy over dx, it means we differentiate. How do we differentiate that fraction? We use quotient rule, and this is quotient rule here. That's the formula for quotient rule, which you can get from the formula booklet, although it's given slightly, it's written differently. The one at the top is called the u, the numerator is u, and the denominator is v. So u is 5x squared plus 10x. Du over dx would be 5 times 2 is 10x, and you differentiate 10x, you get 10. V is the denominator, x plus 1 all squared. When you differentiate that, the 2 comes in front, it becomes 2 bracket x plus 1. Now, we've differentiated it now. We know what v is. We know du over dx. We know u. We know dv over dx. And we know v squared. We put them in. So we put them in that quotient rule formula. So that's v squared. So we have here v at the bottom times du over dx, which is 10x plus 10. That's du over dx. Minus u, which is this one, times dv over dx, which is this one, all divided by v squared, which is that v squared. And now with the long expression like that, you want to cancel out. So if you notice, there's x plus 1 there, x plus 1 there, x plus 1 at the bottom here. So one of them would cancel. This would cancel, you'll be left with one of them. This would cancel. This would cancel. You go from 4 to 3 of them. Now you will write it out. X plus 1 bracket 10x plus 1. So 1x plus 1, 10x plus 1 minus 5x squared plus 10x times 2. This x plus 1 has gone. And this will be now x plus 1 cube, because one of them has gone, so you're left with 3. Now, when you remove the bracket, you get 10x squared plus 10x plus 10 plus 10 minus 10x squared minus 20x. So you expand the bracket at the top. Now, 10x squared will cancel with 10x squared. 10x plus 10x will be 20x minus 20x will be 0. So you are left with 10 at the top on the numerator. And the denominator stays the same, which is what they wanted you to show. So this 10 is like this a at the numerator, and the 1x plus 1 all cube is the same like that. So your n is 3. That's what they wanted you to show. So QED, quod erat demonstratum, as required to show. For 3b, it says, hence, deduce the range of values for x for which dy over dx is less than 0. So instead of dy over dx, we're going to put 10 over x plus 1 all cube is less than 0. So the numerator is 10, which is a positive number. It's positive 10. The numerator is positive 10. So we cannot change nothing with that. So we want the denominator has to be less than 0. If we want all of this to be smaller than 0, to be negative, all we can change is the denominator, because the numerator is always positive 10. So we need the denominator to be less than 0. So the denominator has to be less than 0. So that means x plus 1, all cube has to be less than 0. Take the cube to that side, it becomes cube root. Cube root of 0 is 0. So x plus 1 should be less than 0. Plus 1 goes to this other side, to the right, it becomes minus. So x should be less than 1, minus 1. So when x is less than minus 1, this dy over dx is less than 0. Question number 4. Find the first three terms in ascending powers of x of the binomial expansion of 1 over square root of 4 minus x, giving each coefficient in its simplest form. To get the first three terms in a binomial expansion, we will use this formula there. So that's the formula for binomial expansion. And you get that from the formula book. So we need to put 1 over square root of 4 minus x in a way that we can expand it. So the square root can become x to the power half. And if we take it to the top, it becomes 4 minus x to the power minus a half. So you need to take out a factor of a to the n out of the expression. So if we take out our a to the n, if we compare it now, our a is 4, our b is bx is like this, our x, and our n is minus a half. So what comes out is a to the n. Since our a is 4 and our n is minus a half, so what comes out is 4 to the minus a half. The 4 is the a, the minus a half is the n. And we're left with 1 plus b is minus x, minus 1x over a, which is 4 to the power minus a half. Now, 4 to the power minus a half, it will give you a half. If you put that in your calculator, you get a half. And it will be 1 plus and minus will be minus 1 minus x over 4 to the minus a half. Now you're ready to use the expansion formula. So what you would do is you would have 1 minus x over 4 to the power minus a half. 1 plus minus a half is our n. And then our x is minus x over 4. Plus minus a half is our n. Minus a half minus 1 is minus 3 over 2. All over 2 factorial. And our x squared is minus x over 4 all squared. And when we start to simplify that, we will have half bracket 1 x over 8 plus x 3 over 8 times x squared over 16. So that's what you get. And then when you multiply by the half, you get half plus 1 over 16x plus 3 over 256x squared. And the next part, the expansion can be used to find an approximation to square root of 2. Possible values of x that could be substituted are as follows. Part B says, without evaluating your expansion, state giving a reason which of the three values of x should not be used. We're going to use this formula here. I've circled it there. The expansion of a plus bx to the power n, where n is negative or a fraction, is valid when x is less than a over b. That formula there. What's our a? Our a is 4. Our b is minus 1. So the absolute value of x should be less than 4 over minus 1. So that means absolute value of x should be less than 4. Which means minus 4 is less than x less than 4. So between minus 4 and 4. So which one should we not use? X equals to minus 14. Because goes from minus 4 to 4, minus 14 is well outside. So minus 14 is there, minus 4 is there, and 4 is there. So minus 14 is not in that range. That's why. So the expansion is not valid for x, so absolute value of x greater than 4. So that's what you can write as well. Next one, state given a reason which of the three values of x would lead to the most accurate approximation to root 2. X equals to minus a half. Why? Since the smaller value would give the more accurate approximation. So the smaller the value, it gives the more accurate approximation. It is closest to 0, so it will give more accurate approximation. Question number 5. Write f of x in the form a bracket x plus b all squared plus c, where a, b, and c are integers to be found. So this is where we start, and this is where we end. So you start, you want to end over there. So you notice there's an a out there, so we can take that 2 out of the bracket. So we factorize 2 out, and this 4 is the same as 2 times 2. So it'll be, if you multiply 2 times x squared is 2x squared. 2 times 2x is 4x. So this will be 9 over 2, because 2 times 9 over 2 is 9. Now we want to complete the square of what is found inside this bracket. Complete the square. You find half of the coefficient of x. The number in front of x, you find half of it. Half of 2 is 1. And then you square it. And then it will be x plus 1 all squared. If you multiply x plus 1 all squared, you get x plus 1 plus x plus 1. That gives you x squared plus 2x plus 1. So we've got the x squared plus 2x, which is the same like that x squared plus 2x. But we don't want this 1. What's the opposite of plus 1? Minus 1. So that's why we minus 1 there. And we have the 9 over 2. So we still have our x plus 2 squared. When we remove that 1, and then 9 over 2 stays the same. So minus 1 plus 9 over 2, it gives you 7 over 2. So your answer, you remove the bracket, 2 times that is 2 bracket x plus 1 squared, and 2 times 7 over 2, it gives you 7. So your A is 2, that your B is 1, and your C is 7. So A is 2, 1, B is 1, C is 7. So that's how you have changed it from one form to another. Question 5b says we should sketch the curve with equation y equals to f of x, showing points of intersection with the coordinate axis and any turning point. The turning point is at the bottom there, which is minus 1, 7. So it comes from there. You change that to minus 1, and then that for the 7 for the y. So this plus 1 there, you change it to minus 1. That's your x is minus 1. And this one is your 7. That's the turning point. So that's one of the reasons why we change it to this form. And where does it cross the y-axis? When you put x is 0, this will be 0 plus 1 squared is 1. 0 plus 1 is 1. 1 squared is 1 times 2 is 2 plus 7 is 9. So it crosses at 0, 9. So you can mark that, and that gives you a U shape you sketch. So the y-intercept is 0, 9. The minimum at minus 1, 7. You must state those coordinates and those points to get the full mark. And if you have a graphics calculator, you can put it on it and see what it looks like. So some people can just put it straight into their graphics calculator, and you will see the y-intercept is 0, 9, 0, 9 y-intercept, and the minimum point minus 1, 7 minimum point. So the calculator will give you that answer, and then you can check with what you have done through algebra. Question 5c. Describe fully the transformation that maps the curve with equation y equals to f of x, onto the curve with equation y equals to g of x. So before is the blue one when you put it in your graphics calculator, and after is the red one. So what can you see visually that has happened? So the minimum point before was minus 1, 7. That was the minimum point there. Minus 1, 7. That was the minimum point there. But what is the minimum point after? The minimum point after is 1, 3. So what has changed the minimum point? So what's the difference? The difference between after minus before. 1 minus minus 1 will give you 2. 1 minus minus 1 will give you 2. And then 3 minus 7 will give you minus 4. So the difference is that 2 and minus 4. That is what has been translated by. So it's translated by 2 for the x and minus 4 for the y. So 2 plus 2 to the right and minus 4 down. So the minimum point has translated plus 2 to the right, 1, 2, and minus 4 down. That's what that means for the new graph. And you can see the minimum point there, 1, 3 for the new one. Find the range of the function h of x equals to that. So this is where we start, and this is where we end after we. So we started with that. The 21 stays the same in the numerator. The denominator, we completed the square and have it like this. Now, if you put 2 times minus 1 plus 1 all squared plus 7, it gives you 7. And so the maximum value is when 21 divided by 7, 21 divided by 7, or when x is minus 1. So when x is minus 1, all of this would be minus 1 plus 1 is 0, 0 squared is 0 plus 7. So it's 21 over 7. 21 over 7 is 3. So you're going from 0 to go from 0 up to 3. And if you look at the curve there, it starts from this bottom point there, 0, and it goes to this top point, 3. So that's what the range is. From 0 up to 3. That's the range there. So it's less than 0. It doesn't include 0 because it doesn't touch this line. It does not touch this line x, y equals to 0. So that's why it says less than. So it starts from 0, less than 0, and then it goes up to 3 because it touches that point 3 there. So that's what the range is. And even if you change the scale for that graph to see it, you can see even when you get to minus 37 on the x and plus 38 on the other end, you can see it comes closer to 0. It shouldn't really be touching it. And then the top is 3. So 0 up to 3. And that's what they call the range. So when you change the scale, it does not go below 0. Try it for yourself with your graphics calculator from minus 40 to 40. You will see it never goes below 0. And it never goes above 3. And this is some definition on how to find the range of a function. So you could follow these instructions when you have future questions to help you find the range of a function. You write down y equals to f of x, solve the equation, find the domain, and then if you can't solve it, you use a graph to find the range. And that's what we've been using the graph to find the range. And how to find the domain and range of a function. Another way is to identify function is by using graphs, because domain refers to the input values, and the input values are the ones on the x-axis, and then the range is a set of possible output values which are shown on the y-axis. So read those, and that will help you to do future questions. So that's question 5, but question 5, that's question 5A and B. Question 5C, part 1. Question 5C, part 2. And the rest of question 5. Question number 6. Solve for minus 180 to 180 degrees. 5 sine 2 theta equals to 9 tan theta. So we can write sine 2 theta as 2 sine theta cos theta. You must remember that conversion. We can write sine 2 theta as 2 sine theta cos theta. The 5 times the 2 will give us 10. And we can write tan theta as sine theta over cos theta. You must remember that. Now we can take cos theta to the left hand side, multiply it to the left hand side. So this cos on the right will multiply with the cos on the left, and that will give you the cos squared, because there's 2 of them now. So you got 10 sine theta cos squared theta is equal to 9 sine theta. We replace the cos squared theta with 1 minus sine squared theta. Replace cos squared theta with 1 minus sine squared theta. So when you do that, all the cosine will disappear. You only have things with sine. 10 sine theta minus 10 sine cube theta minus 9 sine theta. It's all sine theta, sine theta, sine theta. So you can factorize. Sine theta is there, there, and there. It comes out of the bracket. You have 10 minus 10 sine squared theta minus 9. 10 minus 9 is 1. So sine theta is equals to 0 is one option. Or 10 minus sine squared theta minus 9 is equal to 0, another option. 10 minus 9 is 1. You take it to the right hand side, it becomes minus 1. So let's solve the left hand side first. Sine theta is 0. We want between minus 180 and plus 180. Inverse sine of 0 is 0. So when is sine inverse sine of 0, 0 is at 1 minus 180, 0, and 180 degrees. You can plot the graph of y equals to sine x, and you can see it yourself. So 0 there, 0 there, 0 there, minus 180, 0, 180. And this one, minus 10 will go to the right. It becomes divided by 1 over 10. So minus 1 divided by minus 10 will give you plus 1 over 10. What's the opposite of squared? Square root. So you find square root of 1 over 10, which will be minus square root of 1 over 10 and plus square root of 1 over 10. So if you have this minus 0.223, when you plot the graph, you make that value less negative. Less negative, if you have minus 0.223 from here, to make it less negative, you want to get in something which is on this other side. So you want to get a number which is going to the right hand side. These are less negative. So you can use 0.2, minus 0.2, or minus 0.1, a bigger number. If you look at the various graphs here, the original one is the blue one. If it's going slowly, if you use minus 0.1 instead of minus 0.2, you'll get this red one. And if you use minus 0.2, you'll get this green one. So the red one is decreasing the slowest because you can see it's coming down gently, but the blue one is coming down faster. This one is coming down gently. So that's what it means by making it less negative to decrease slowly. And for part B, you can also do it on the calculator. Once you have done your graph on your calculator, you can use something they call enter the x value. And when you put x is 10, so you press G solve on your calculator and go to Y calculate, and you put x is 10. When you put x is 10, it will give you a Y value of 2,150. That's how you can use the calculator to check your answer is correct. So that is question 7. The answer to question 7A, where you would substitute these values and then you work out K to be 0.223. Answers to question 7B and 7C. For 7B, you substitute the value of 10 for T and put in your calculator, you get 2,150. And then for 7C, make minus 0.223 less negative. And these are graphs to compare which one is steeper. This one is less steep, this one is steeper. And less negative means numbers to the right of 0.223, minus 0.223. So that's part question 7C. Question number 8. Figure 2 shows a sketch of part of the curve with equation y equals to x bracket x plus 2 bracket x minus 3. Part A, show that the exact area of R1 is 20 over 3. To show that the exact area of R1 is 20 over 3, we need to integrate. And to integrate, we need to expand this, multiply this trinomial. So when you multiply it out, you will get x cubed minus 2x squared minus 8x. So you do the first two, x squared, x times x is x squared, x times 2 is 2x, and then you multiply with x minus 4. Or you can do this 2 first, and then after you multiply with x, because it is multiplication is distributive, you can choose any 2 and do first, and you get this x cubed minus 2x squared minus 8x. Now you want to integrate from minus 2 up to 0. And we're using this formula for integration. Add 1 to the power, divide by the new power. So you add 1 plus n divided by n plus 1. So when you integrate that, you would get x cubed, you get x to the power 4 divided by 4. And then you do the same for integrating 2x squared and integrate 8x. So when you integrate, you will get x to the 4 divided by 4. Add 1 to that 2, you get 3. And then you divide by 3. Add 1 to that 1, you get 2. And you divide 8 divided by 2, you get 4. And you would substitute the value 0 first, and you substitute minus 2. When you substitute 0, you put 0 there, you put 0 there, and you put 0 there. All of that will be 0. So that's what you get. You get 0. After that, you put minus 2. Minus 2 there, minus 2, minus 2. and that would give you 4 minus 16 over 3 minus 16. And you put it in your calculator, you get 20 over 3. QED, because it says show that. So as required to show. Part 8b, the region R2 also shown shaded in figure 2 is bounded by the curve, the positive x-axis, and the line with equation x equals to b, where b is a positive constant. Part B says verify that b satisfies this equation. So what you want to do, you want to expand and then you compare. And we know that R2 is minus 20 over 3. So R2 is that area there. And we know that's equals to minus 20 over 3. And the minus is because it's below the x-axis. So the minus is because it's below the x-axis. So, and we got that from integrating from 0 to b, and that gives you 20 over 3. So when we have this expression, if we multiply by 12 on all through times 12, that would give us, and then we can factorize to get that. But if you just multiply by 12 to go from this step to this step here, the 4 will cancel. 12 divided by 4 is 3. So you get 3b4. 12 times minus 2 divided by 3, that will give you 8. 12 times that divided by 3, that gives you 8. 12 times minus 4 gives you minus 48. And then when you multiply this by 12, and then you divide by 3, you get 80. But if you want to form an equation which is equals to 0. Now, the part where you want to show that the two equations are the same, very important. So what you want to do is you take the answer that is given in the question, change it to look like that, so that when you change the other one, you can compare them to look the same. So if you expand b plus 2 all squared, that will give you b squared plus 4b plus 4. Now, the two equations are the same because if you were to multiply, you can multiply it out. Follow those lines there to multiply it out. You will get this expression underneath. And 3b to the 4, you got that, minus 20b cubed and 12b cubed will give you minus 8b cubed, plus 20b squared and minus 80b squared and 12b squared will give you minus 48b squared. So after that, you can compare and you can see that the 3b4 is equals to that, 8b cubed, 48b squared, 80 is the same, and the 0. So you have shown that they're equal. So what you have done, you have changed the answer to a new form so that you can compare them. It's quicker and easier that way. So in the exams, they'll give you a mark for rearranging the equation to get the quartic equation, a quartic equation like that one. You get a mark for expanding the equation and a mark for showing and stating that the equations are the same. So stating that this equation is the same like that equation. Question 8c. Explain with the aid of a diagram the significance of the root 5.442. So what's the significance of 5.442? So between x equals to minus 2 and b equals to 5.442, the area above the x-axis is the same as the area below the x-axis. So that is what you want to say. the area above the x-axis is the same as the area below the x-axis. You can also look at it this way. The area above the x-axis, you can see there is 36.03, this top area above the x-axis. Is the same as this one, arrow 4, which is 36.03, which is the same the area below the x-axis. So 36.03 for the area below the x-axis is the same as the area above the x-axis, 36.03. That's what you need to say. Or you can state that the area between 1.225 and 4 is the same as the area between 4 and 5.442. Or you can say the net area is minus 20/3. So that's what you need to show and to say. And for those who use their graphics calculator, you can put this in your graphics calculator, the integration. Use that integration part in the graphics calculator, that integration symbol there. From -2 to 0, you'll get the answer of 20/3. But you need to show you're working in an exam. So this could just be a way to check if your answer is correct. And first, if you plotted your graph on the calculator, this is the view window which you can use. And you would plot the curve, y1, the blue, and then the green line is there. And that would give you, you can work out this point where it crosses the y-axis. You can work out that point where they meet. You can work out that point there. So the graphics calculator can work out those points for you. So this is just for you to be able to do it and check certain things. That's question 8. That's the first part to question 8, question 8a, question 8b, still question 8b, question 8c, still question 8c, using the calculator to find the integral, and how to plot the graphs on the graphics calculator. So for this question 8, the first 6 marks in this question relating to definite integral with the area under the curve was straightforward, and lots of students would do this correctly and had the mark. But only the best candidates were able to get the last 4, with many struggling to explain the last part of this question. And when this exam was marked, most students could not give full explanations to the significance for part C. And only the very best candidates could do that. So be careful with that when you do your own exams. Look out for things like this and make your explanation clear. And for part B, students were confused between the -20/3, what it meant. So it's very important to think about these things when you do your exams, and try not to make things very complicated when you want to prove things. Look at them in easier ways. Okay, I hope that helps for this question. Question number 9. Given that A is greater than B is greater than 0, and that A and B satisfy the equation, show that A is equal to B squared over B minus 1. So we start with log A minus log B is equal to log of A minus B, and that's where we want to end. So the way you do this kind of questions, you look at where you start and where you end. What do you see in the start and what do you see in the end? So that you can start to know what you can change. If you notice there's logs in the start, but in the end there's no log. So that means we have to eliminate the logs. We have to do something and get rid of them. So we start by thinking about the formula for logarithms. So log A minus log B is the same as log of A divided by B. So we can start by putting this first one, log A minus log B we put it as log of A divided by B. That equals to log A minus B. Now we can remove logs on both sides. So A over B is equals to A minus B. So once you've taken out the logs, you can take B to the right-hand side. So A becomes B bracket A minus B. And then you remove the bracket. So A is equals to BA minus B squared. Now minus B squared goes to the left. It becomes plus B squared. And A goes to the right. It becomes minus A. You factorize. A will come out of the bracket. And you're left with B minus 1. So that means A is equals to B squared divided by B minus 1. QED. Quod erat demonstratum, as required to show. Question 9b. Write down the full restriction on the value of B, explaining the reason for these restrictions. So B is not equals to 1. So it's not defined at B equals to 1, because if you put 1 there, 1 minus 1 is 0. So B squared over 1 minus 1, B squared over 0 is not defined. You cannot divide by 0. And B is greater than 1. Since A is bigger than 0, B squared over B minus 1 is bigger than 0. So B is bigger than 1 since B squared is positive. So for this to be positive, B has to be bigger than 1. If it is less than 1, this will be negative, and positive at the top, negative at the bottom will give you negative. So B minus 1 has to be bigger than 0. Since the B squared at the top is positive, this one below has to be bigger than 1 to be positive as well. So then A is greater than 0. So that's question 9A, and that's question 9B. So from the examiner's report, there were many good attempts to this question, and most students were able to achieve the first part, but the part B was only for the very best students who could do it. But what happened was some of the students could not remember this log A minus log B. Some of the candidates could not remember that formula, and that is why they couldn't gain that mark. But for those who remembered it, they will be able to do it properly. And for the part B, there was a bit of difficulty for some students to know what infinity or undefined is. So that's why they couldn't get part B done properly. Question number 10. Prove that for all n an element of natural numbers, n squared plus 2 is not divisible by 4. For this question, you can use an algebraic proof. So you can use n is equals to 2m, and so n squared plus 2 would be 4m squared plus 2. And you conclude that this number is not divisible by 4. If you use that as the explanation is trivial. For n equals to 2m plus 1, n squared plus 2 would be 2m plus 1 all squared plus 2. And you have to have correct working, and you conclude that this number is in the 4 times table and add 3. So it cannot be divisible by 4. Or you can write it as 4 bracket m squared plus n. So what you're doing is you are using an even number 2 times. An even number is like a multiple of 2. So like 2 times 1, 2 times 2. So you can call it 2m. Multiplied by 2 is an even number. So you put 2m, replace n with it. So it becomes 2m squared. It becomes 4m squared. But if you look at 4m squared plus 2, 4 times m squared is a multiple of 4 because it's times 4. but with 2 added to it, you've added 2 at the end. So it cannot be divisible by 4, because times 4 means a multiple of 4, but when you add 2, it cannot be divisible by 4. Now you try with an odd number, because we've done it with an even number. We try with an odd number. An odd number is 2 times m plus 1, because 2 times m is even number, and when you add 1 to an even number, you get an odd number. So 2m plus 1 is an odd number. So we would use 2m plus 1 squared, put it there, 2m plus 1 squared plus 2. And that will give us 4m squared plus 4m plus 3. We can factorize 4 out. So you get 4 bracket m squared plus m plus 3. This is 4 times bracket m squared plus 3. Because you're multiplying by 4, it's a multiple of 4. But when you add 3, you cannot divide by 4. So 4 times m squared plus 4 is like, 4 times table, 4 times 1, 4 times 2. But when you add 3, it cannot be divisible by 4. So you can say, hence, for all n an element of natural number, n plus 2 is not divisible by 4. So remember, the idea of proof is something which is new in this specification, and it is not well known, and most students did not answer this question. So when you're revising, make sure you learn these ideas of proof, and that would help you to be able to do this type of questions in the exams. So for part 2, given that x is an element of R, the value of 3x minus 28 is greater than or equal to the value of x minus 9. State given reason if the above statement is always true, sometimes true, or never true. So you will say the statement is not true for between 9.25 and 9.5. For example, pick a number in the middle of that, 9.4. If you put 9.4 there, 3 times 9.4 minus 28, 0.2. And if you put 9.4 there, 9.4 minus 9 is 0.4. So that shows that 0.4 and 0.2. The statement is sometimes true. For example, if you take a number like 12, if you put 12 there, 3 times 12 minus 28, it gives you 8. And 12 minus 9, it gives you 3. And you can also do it on a graph if you are using the graphics calculator. So there are points where 3x minus 28 is less than x minus 9, and points where 3x minus 28 is greater than x minus 9. So 3x minus 28, the absolute value is the one in blue, and x minus 9 is the one in red. So that's 3x minus 28, and that's x minus 9. So there will be points where the blue graph will be below the red one, and the points where it will be above. So that's the view window, your settings, so that you can see it clearly. And you can see here, these points marked here. So this part is below, the blue is below the red on this part, and in this one is above there, and it's above there. So the graphs can help you to see the points where 3x minus 28 is below x minus 9. That means where the blue graph is below the red line. So that's more another part of the graph. So statement is not true for 9.25 less than x less than 9.5, because that part it doesn't satisfy the conditions. Question number 11. A competitor is running a 20 kilometers race. Part A, show that her time to run the first 6 kilometers is estimated to be 36 minutes 55 seconds. So we can use this formula. New value is equals to original value times multiplier to the power n. So when n equals to 1, you get 6 times 1.05. When n equals to 2, 6 times 1.05 to the power 2. And how did we get the multiplier? You add 100 to the 5% and you divide by 100. So 5 plus 100, it gives you 105. And 105 divided by 100, it gives you 1.05. So you can get your total, and 1 minute is 60 seconds. So 0.915 minutes is 0.915 times 60, which is 54.9, which is approximately 55 seconds. So you will get 36 minutes and 55 seconds. And you can write it all like that. 24 plus 6 times 1.05 plus 6 times 1.05 squared. And you put that all in your calculator at once, you'll get 36.915, and you change the 0.915 to seconds, which is 55 seconds. Part B, show that her estimated time in minutes to run her R kilometer for 5 less than R less than 20 is 6 times 1.05 to the R minus 4. So 5th kilometer is 6 times 1.05 to the power 1. 6 kilometer is that 7, and then the R kilometer is that. That's how you can look at the first kilometer, 6 minutes, second 6 minutes, third 6 minutes, fourth 6 minutes. The fifth would be 6 times 1.05 to the power 1, because 5 minus 4 is 1. The sixth would be 6 times 1.05 to the power 2. 6 minus 4 gives you 2. And for the 7, 6 times 1.05 to the power 3, because it's 7 minus 3. So the 7 minus 4, it gives you 3. 6 minus 4, it gives you 2. And it will be 8 minus 4 gives you 4. And for the arrow, it will be arrow minus 4. So that's how you get that. Number 11C, estimate the total time in minutes and seconds that would take to complete the race. So the first 4 kilometers added to the time taken from 5th to 20th kilometer. So you would have 24 plus, you start from 5 and you end at 20. So you start from 5, you end at 20, and you want to use this expression there, which you can use a calculator to do that for you, or you can use the geometric formula. S equals to A, the sum. Get this from the formula book. S equals to A bracket 1 minus R to the n over 1 minus R. And A is 6 times 1.05, and R is 1.05. N is 20 minus 4, which is 16. So you substitute N is 16, R is 1.05, and A is 6.3. And you work that out, and it gives you total time of 173 minutes and 3 seconds. So the total time should be given in minutes and seconds. So this is a table which you can generate this table from your calculator. You have these kilometers, time per kilometers, and then the total time. So that's something to show you to think about. Question number 12. Show that the x-coordinate of the turning point of the curve with equation y equals to f of x satisfy the equation tan x is equals to 4. So what you want to do is you got f of x, because it says turning points, that means you differentiate. Because turning point dy over dx equals to 0. So f dash of x is the same as dy over dx. That means you differentiate f of x. And then you put it equals to 0. dy over dx is equals to 0 at turning points. So when you differentiate that, you put it equals to 0. So either e to the minus 0.25 x is equals to 0, which you would ignore that because that's not possible, or this expression is equals to 0. And that means 10 cos x is equals to 2.5 sine x. We want to take cos x to the right side. So we divide by cos x. And then you take 2.5 to the left. And you divide by 2.5 on the left. So you got 10 divided by 2.5 is equals to sine x divided by cos x. Sine divided by cos is tan. So sine x divided by cos x is tan x. You must remember that. So that means tan x. 10 divided by 2.5 is 4. QED as required to show. For question 12b, you can see that as it bounces, the height decreases. So decreasing height. And make sure the height is above the x-axis. It's bigger than 0 and it's decreasing, it's coming down. This one is taller, shorter, keeps going down. The height is decreasing. And if you put it in your calculator, plot in your graphics calculator, use this view window so that you can see it clearly. And that's what you will see if you do it in your calculator. For question 12c, use this model to find the maximum height of the ball above the ground between the first and second bounce. So you can see here, that's the height at second bounce. So dy over dx is equals to 0. If you use your calculator, dy over dx is equals to 0. So x will be 4.47 and you get y to be 3.1. So that's the calculator telling you the answer. But let's do the working now to show it. So you know tan x is equals to 4, x equals to 1.326. So t is equals to pi plus 1.326. That gives you 4.47. So you want to solve tan x equals to 4 and substitute into h of t. So inverse tangent of 4 is 1.326. And tan repeats every 180 degrees, or pi. 180 degrees is same like pi radians. And if you have h of t is 10e to the minus 0.5 t sine t, you want to replace t with 4.47. So you replace t with 4.47. Put that in your calculator. That will give you 3.17 meters. For question 12d, explain why this model should not be used to predict the time of each bounce. The time between each bounce should not stay the same when the heights of each bounce are getting smaller. As the height is getting smaller, the time does not stay the same. That's question 12. Question 12a. Question 12b. Question 12c. And question 12d. Question number 13. The curve C with equation y equals to p minus 3x over 2x minus q bracket x plus 3, where p and q are constant, passes through the points 3.5, and has two vertical asymptotes. Explain why you can deduce that q equals to 4. And the asymptote is found where 2x minus q equals to 0. So 2x minus q equals to 0, hence q is equals to 4. Now, if we have 2x minus q equals to 0, and we are told that x is equals to 2. So 2 times 2 minus q equals to 0. 2 times 2 is 4. 4 minus q equals to 0. Take q to the right-hand side, it becomes positive, so q equals to 4. Part B says, show that p is equals to 15. We substitute x equals to 3, y is equals to a half, and q is equals to a 4. So you follow those blue line, x equals to 3 there, x is 3 there, x is 3, and then y equals to a half, and q equals to 4. So you simplify that and you cross multiply. So 2 times p minus 9 is equal to 6 minus 4 is 2. 3 plus 3 is 6. So 2 times 6 is 12. So it'll be 12 times 1. So that's 12 on the right hand side. So and then you divide by 2 first. So p minus 9 is equals to 6. 12 divided by 2 is 6. You take minus 9 to the other side. P is equals to 6 plus 9. That gives you 15. Figure 4 shows a sketch of part of the curve C. The region arrow shown shaded in figure 4 is bounded by the curve C with x-axis, the line, and the equation x equals to 3. Show that the exact value of the area of arrow is a ln 2 plus b ln 3. So we want to use partial fractions. So we want to change 15 minus 3x over 2x minus 4x plus 3 is equals to a over 2x minus 4 plus b over x plus 3. And to do partial fractions, we have to multiply the denominator there, multiply it by a, multiply it by b. So n of 15 minus 3x is equals to a bracket that plus b that. What we want to do, we want to make a 0. So you think of a number that will make this one 0. What's the opposite of plus 3? Minus 3. So we use minus 3. So minus 3 plus 3 will give you 0. So a will become 0. And you put there, this one will become minus 10b. That will give b to be minus 2.4. And the next thing is we look for what can we put to make b 0. The 2x minus 4 is equal to 0. So 2x is equals to 4. X is equals to 2. So we use x to be 2. When you use x to be 2, this b will be 0. And you will find a to be 9 over 5. So you got a and you know b, which you can write down in the. So we have this integral now. It becomes 0.9 divided by x minus 2 minus 2.4 divided by x plus 3. So 0.9 can come out of the bracket. This will be ln 2. And then when you integrate, you get 0.9 ln 2x minus 4 plus 2.4 ln x plus 3. Now we integrate with going from 3 to 5. So got, if we have 15 minus 3x equals to 0, 15 is equals to 3x, so x equals to 5. So that's how we got the 5 there. Another way is if you have to put the graph in your calculator and you see the point there where it crosses the x-axis, that point is 5, 0. That's where you get the point 5 there. That's where that 5 comes from. 5, 0. And that's where you put the graph there in your calculator. And that's your line x equals to 3. So we get the area by substituting the values for 5 and for 3. And you substitute 5 in there and 5 in there. After that, put 3 and you put 3. And when you put 5, you get all of this expression at the top. And 2 times 5 is 10 minus 4 is 6. 5 plus 3 is 8. 2 times 3 is 6 minus 4 is 2. 3 plus 3 is 6. And then you do the same. 0.9 ln 6. You put these two together and minus 2.4 ln 6. So, and you will get this 0.9 ln 2, 2.4 ln 8. So you put them together and you would end up with, you see, 0.9 plus 2.4. 0.9 plus 2.4 will give you this 3.3. 0.9 plus 2.4 will give you 3.3. And 7.2 and 0.9 will give you 8.4. So it gives you 8.1. And then you can put them together. And remember, 2.4 ln 8. 8 is the same as 2 cube. 2 times 2 times 2. So the 3 can come in front. So 3 times 2.4 gives you 7.2 ln 2. That's how we got 7.2 ln 2 there. Because we changed the 8 as 2 cube and put the 3 in front. And now you can change 6 as 3 times 2. 6 is the same as 3 times 2. So it's 3.3 ln 3 plus 3.3 ln 2 minus 8.1 ln 2. And now 3.3 minus 8.1, it gives you minus 4.8. So you have 3.3 ln 3 minus 4.8 ln 2. That's what you get. And you can swap them and put minus 4.8 ln 2 in front and 3.3 ln 3 at the end, so that you have something similar to what they want you to show for the area. And you can use your calculator to check. If you put the integral, don't forget, use the integral of that expression dx, you get 0.2983. And if you put 3.3 ln 3 minus 4.8 ln 2, you get 0.298. So if you notice, the two answers are the same. So your two answers are the same. That means you have done it correctly. That's how you can check your answer using the calculator. Very important to do that, especially if you've done a long question where you don't have time to go back to check all the mistakes. So very important to be able to use the graphics calculator to do it. You can watch some of my videos on how to use the graphics calculator, or subscribe in my channel and you will see all the different types of ways to use the graphics calculator to check your answers for A-level exam questions. Question number 14. The curve C in the standard Cartesian plane is defined by the equation. Part A, find the value of dy over dx at the origin. So x is equals to 4 sine 2y. We're going to use this formula here. Dy over dx is 1 over dx over dy. You need to remember that. So dx over dy, you differentiate with respect to y, it will be 8 cos 2y. And dy over dx will be 1 over that. So it will be 1 over 8 cos 2y. So when y is equals to 0, so dy over dx, you substitute y is 0. 1 over 8 times cos 0 is 1 over 8. So at 0, 0, dy over dx is 1 over 8. Part B says use small angle approximation. So sine 2y is approximately 2y. So that means x is approximately 8y. This is a small angle approximation formula. Sine theta is approximately theta. Tan theta is approximately theta. So that means x is equals to 4 times 2y, which will gives you 8y. And part 2, explain the relationship between the answers. So that when x and y are small, x equals to 4 sine 2y approximate to the line x equals to 8y. You can rearrange x equals to 8y to get the equation of a line, because line is y equals to mx plus c. So from the first part, from bi, y equals to 1 over 8x. You take 8 to the other side, you divide. So y equals to 1 over 8x. So m is 1 over 8, and the intercept is 0 on the y-axis. From part A, dy over dx is 1 over 8. So the value in A is the gradient of the line in B. So the gradient here is the same like this one. So the value in A is that gradient there. That's what we're saying. For part 14C, we want to show that for all points x, y line on C, dy over dx is equals to that. So we know dy over dx is 1 over 8 cos 2y. So we got here, we can divide by 4. So we got sine 2y is equals to x over 4. Remember that. Going to use it. And we need to use sine squared 2y plus cos squared 2y equals to 1. And cos squared 2y will be 1 minus sine squared 2y. So we have x equals to 4 sine 2y. So that means sine squared 2y is equals to x over 4 squared. So we square that and square that. If we square sine squared 2y, we square the other side. Now we know cos squared 2y is 1 minus sine squared 2y. So it's 1 minus x over 4 squared. We'll replace sine squared x over 4 squared. Now take the square root. Cos 2y is square root of 1 minus x over 4 squared. Which we can, from there we know we want to change it to look like that dy over dx equals to that. So we know cos 2y is square root of 1 minus x over 4 squared. And then we got dy over dx is 1 over 8 cos 2y. So 1 over 8, and then there's the cos 2y. We can look here to simplify it. 1 minus x squared over 16 becomes 16 minus x squared over 16, which is 16 minus x squared over square root of 16, and becomes square root of 16 minus x squared over 4. And this 4 times 8 divided by 4 will give you 2. And you would end up with 1 over 2 square root of 16 minus x squared. So that 2 is like your A. So A is 2. The 16 is your B. So you have found A and B. So that's question 14. That's question 14A. Question 14B. Question 14C. And the last part of question 14.